The internationalization of higher education that began in the 1960s has expanded under the requirements of the General Agreement on Tariffs and Trades in Services. These agreements have focused on mutual recognition through accreditation and assessment of professional practice. Now, new technologies such as portable computers, internet, smartphones, and others have created a new virtual space that connects professionals across the globe without regards to borders. Traditional industrial societies are no longer the leaders in growth. Developing nations have taken on this role. Leading the way are China and India with their rapid industrialization and vast populations. These nations are home to an expanding middle class, whose demands on resources and technologies will be unparalleled in history. This new reality is affecting the migration of engineers. More and more engineers who left their home countries for training and a better life in developed nations are returning home to take advantage of emerging opportunities. This has led to a transnational individual, one who works and has residence in more than one country. Transnational engineers can now transfer skills and ideas from developed nations and use them in their home countries to further fuel development. For example, Taiwan is now home to one of the largest venture capital industries outside North America. This is due to the return of transnational software engineers from Silicon Valley, bringing with them American techniques of raising capital. Although technology has changed faster than anyone predicted, social change has been much slower. Issues of communication, professional and social ethics, and diversity have remained relatively unchanged since the 1980s. These issues have become increasingly important as engineers become involved with progressively larger, more complicated, and socially important schemes involving energy, the environment, and food production. Concurrently, engineers are pushing further into the realms of bio, nano, and info, across disciplines into biology and medicine. Here, communication and teamwork take on a new importance. As the 21st century progresses, engineers can expect to see more interdisciplinary convergence. New technology and methods of communication have made engineering increasingly borderless and eroded the barriers between disciplines. Furthermore, the new, growing, and virtual mobility of engineers through cyberspace has changed the balance of supply and demand, forcing institutions to think globally. In the future, engineers from developing countries, like India and China, will represent an increasingly larger proportion of the profession. These technological and demographic changes are forcing interdisciplinary and international convergence. As a result, engineering schools are integrating global, social, and environmental considerations into their technical courses. Future engineers will have to acquire much higher levels of education and learn new entrepreneurial and innovation skills. Creation of new knowledge and the ability to apply this is now key to the strength of a nation. These pressures are forcing engineering education to become more dynamic. This in turn raises questions involving basic knowledge, expertise, computer and technical literacy, and human relations. It was once estimated that half of mechanical engineers' skills would become obsolete in 7.5 years, 5 years for an electrical engineer, and 2.5 years for a computer engineer, less time than it takes to earn a degree. Today, these time spans are even shorter. Not only that, but technical advancement has shortened the life cycle of products, and engineers find themselves switching jobs more often. Furthermore, global competition is forcing companies to downsize, placing even more pressure on engineers to develop their skills. Historically, engineering training responded to workforce needs as new technology was introduced. Now change is so rapid, education cannot keep up. Instead, it must concentrate on keeping aligned with technological change. Modern engineers and employers must work in real time in order to maintain their standing as creators of wealth in the knowledge economy. To do so, they must use tacit knowledge, which drives their day-to-day practices, shift to knowledge driving economic value, and participate in real-time knowledge flows, move to knowledge creation, link to learning systems that help engineers develop their talents more rapidly, shift focus to sustainability and technological innovation. Despite the changes in society and technology, engineering will always exist. But as a coherent and independent profession, it may become unrecognizable. Engineering was once viewed as a means to exert control over nature and natural forces. Now it exists in a hybrid world where nature and human processes are intermingled. There is no longer a clear boundary between autonomous, non-human nature and human-generated processes. Consequently, the reality on which engineering ethics are called upon to reflect has changed. Future engineers may have to learn some aspects of the liberal arts and study history, culture, and philosophy. In the future, engineers must understand the basis of science and the fundamentals of engineering principles, be able to conceive, design, and operate increasingly complex systems, be adept at product development and manufacturing, be creative and innovative, be conversant with computing and information technology, write and communicate well, appreciate and draw upon diversity, think clearly about ethics and social responsibility, know how to merge the physical, life, and information sciences when working at the macro and nano scales, work within a framework of sustainability, understand business and organization, and be prepared to live and work as global citizens.